Good evening, everyone. Thank you for being here tonight. How are you doing? Yeah. So my name is Quan, and tonight I would like to talk about exploring the attack surface management with with generative AI. So specifically, we'll be exploring how we can enhance ASM or attack surface management in this case, and how we can leverage technology like generative AI and OSINT. So this presentation is for all of you who are working in the security industry, and who looking for using the new technology to solve their own problems, whether you are the security analyst or penetration tester or security managers. I hope this discussion will be valuable for you tonight. So before we dive in, so here does a little bit about me. I have more than 12-year working experience in IT industry. I have gone through several positions like database administrator, system administrator, or senior data security officer, or I am coordinator. Currently, I'm working for the AI with as a position as a AI security and data security advisor. I'm also holding the Master of Cybersecurity Analysis and Master of Research from Macquarie University. I'm interested in the AI security and AI for cybersecurity or AI-driven solutions. So connect me that if you interested in these three major research. So here the week's look overview of the tonight. So we will start with foundation of overview of the ASM, open source intelligence, LLM, and AI agents. And then we introduce the key technology that's to bring together, like the Langchain React framework to create the architecture or proposed architecture for this kind of system. And later, I will do some live demo, and we will see that the application of the system in a real case. And after that, we will discuss about challenges and the future improvement. And finally, I will talk about the conclusion and discussion about the talk tonight. So first thing first, overview about the attack surface management. So what is attack surface management? So attack surface management is a continuously process that is discovering, inventorying, and classifying and prioritizing all of your digital assets and vulnerability that the attacker can potentially exploit. So thinking about that, you thinking about your whole digital footprint on the internet. So thinking like the mindset of the attacker, they will look for the windows and the gate to infiltrate your castle rather than go to the front gate. So the goal is that we need to reduce the number of entry points that any adversary that they can leverage to infiltrate to your organizations. And next we do about OSINT. OSINT or open source intelligence. So basically that open source intelligence is a type of practical that gathering and collect publicly information from the internet. So in the context of the cybersecurity, so OSINT is like that you have, for example, that your website, your social media posts, your forum discussion, or sometimes your code repository like GitHub. So that means that our DNS record. And the key is that those information that anyone can find on the internet. And that's a problem that when we apply OSINT to the ASM, and we're not just looking for the internal access, we're also looking for searching for external information that can reveal the weakness, or sometimes we discover that the digital asset that you have never know that it exists or not. So next we move to the LLM, so the large language model. Nowadays you will see that a lot of talk and article about generative AI, about everything, and the large language model is a type of AI that have been trained by the massive text data and code. And they are excellent at understanding the context, summarizing informations, and generating new text. So how the OSINT data and LLM can cooperate together? So imagine that you have the LLM model that can have the capability to go through 1,000 lines of the OSINT data that you collect, and it can give you some find connections or find some vulnerability or threat that human may miss during the analysis phase. So thinking about that LLM that can act at the information analysis, helping us to make sense when we see a lot of vast amount of data from the internet through the OSINT. So we talk about the AI agent. So what is the AI agent? So why LLM is a brain? So AI agent will act as the give that the brain have the hands and feet. And an AI agent system is can take the objective and reasonable on it and take a series of action to achieve that objective. So in our ASM context, an AI agent can be tasked with a mission, for example, that find all potential attack vector for company X. So in this case, that the agent can perform the OSINT gathering and feed that data to LLM model for further analysis, and then present a structured report, for example, like JSON format or XML format. So we are talking about the automating the whole entire workflow from data collection to threat reporting. So to make these AI agent and LLM model work together effectively, we need a framework, and so that is where Langchain's React come to the place. So what is React? React means reasoning and acting. So it's a method that allows the LLM not only think about the problem, but also decide which tool to use and what action to take. So for the framework like Langchain, it's a critical component to create intelligence and dynamic security agents. And so what happens when we all combine this technology together? We may have the highly automated and intelligent system for attack surface management. Instead of that, you're thinking about the security team that they have to spend countless hours and hours just to do searching on the internet or do semi-auto just to find discover any hiding asset on the internet. We have the AI agent that can help us to continuously and performing the passive reconnaissance to gather the OSINT data, and also it's use the Langchain framework to pass the data, to process data, to identify any potentials threat on vulnerability that the human analysis may have not the time or resource to find. So thinking about that, this type of system that can help leverage your security team that can not just focus on more complex activity like threat hunting or actual mitigation activity rather than initial discovery phase. So what we have here, that's I would like to introduce that a proposed architecture. So first thing first, that I have the data gathered through OSINT tools, and after the OSINT data, it can pass through the generative AI model, and with the Langchain framework agents, with the defined kinetic model for prompting and reacting, and plus with the AI agent, we'll define the tool to analyze the OSINT data. And what we have at the end, that we have the threat summary report, which will be that's the that's the human. It can be consumed by human analysis or by other further system. It can be JSON format or XML format. So all the system that you have, that after you have the threat summary report, you can feed into the threat intelligence platform, or SIM or EDR or XDR. So here that as you can see here, this is an example of the threat summary report through the generative AI and with the Langchain framework. And you can see here that it's not just the data, it's the very structured data and actionable. And you can see here that we have for example, that you can set the name of the risk like Expo Jenkins instance of domain. And we have the risk score here, and we have also the recommendation. So when we're doing some activity like this, we're not just finding the problem, we also are providing a solution, because that's, you can see here that it's providing that recommendations, what activity you can do to mitigate the threat and risk. So now we come to the exciting part tonight, and I would like to run a demo. And in this demo, it's the live demo. So it's demo that I will leverage a notebook catalog, and with the tool called the Harvester on Google Doc. And the model or the LLM model I will use the Google Gemini Plus 2.5, and the AI agent framework will be Langchain. Please stay tuned, that it will take some time to loading. So here that the first thing first that I will try to do, that I will try to install the harvester from the GitHub. So I will use the latest version of the harvester from the GitHub. So as you can see here, that it start download the harvester and install on the notebook, and we'll see that. And this is the test that if the harvester is successfully installed or not. And next, I will go to the next step, that I will gather the OSINT data. So in this case, I will use the domain. The target domain is the example.com. So be careful if you want to do some experiment like this. So if you choose the domain, please ensure that you have the authority to scan the domain. Otherwise, that is illegal activity. So in this case, I just choose that's the example.com domain that it can you freely to use on the internet. And as you can see here, that is the program is starting to gather the OSINT data from the example.com. I am to gather the email address and the subdomain for further analysis. And you can, as you can see here, that it's just finished the collect the data. So let's see that how many email we found. That we have 48. And how many domain we have? We have 1,456. So next, I will go to set up some environment to do the Langchains and with the AI agent. Yeah, don't worry about the red one. That's just the problem with the Python. That's dependencies sometimes. That is conflict in dependencies. And now I will log my API key, which API key that is the way that I use to communicate between the AI agents with the LLM model. So now I move to the next gathering. We use Google Doc query functions. And what I call, I try to do some gathering on this. Normally you see that this is empty because that we assemble document domain does. There's nothing you can gather about Google Doc. But with the real domains, you can gather many, for example, that you can gather some leaked document there as well, some SQL injection maybe, or some API key leak on the internet. And now the next step I will do that I will try to combine the data that we collect from the OSINT from through the harvester and with the Google Doc data. So we try to consolidate the data into the one big data, and you will see here. So what you can see here, that's either unstructured data, or sometimes that is mixed between data between the list or dictionary from the Python. So how you can, if just a human analysis, that how you can go through the vast amount of data and have some exactly that you can find some threat or vulnerability inside the bunch of the text here. So we come to the final step that now that we try to run the LM model with the Langchain AI agent framework, and you will see that normally that this is the error that we say that the Langchain framework in the future will not be supported, and they will have the new kind of AI agent called LangGraph. This is the kind of upgrade version for the Langchain framework. It will take around 2 or 3 minutes to go through the whole chains. Sorry. Okay. It's symbol.com. Maybe it's symbol.com. Not, don't use the. Can I show you later? Yeah. 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 So as you can see here, that is start chaining, the agent is start chaining, go through the React process, like go through observations, talk, and final chains. So you can see here that's the vulnerability analyzer is start action, and it show you the bunch data that we collect or we combine in the reverse step. And now you will see this is start producing the observations. So because that's through the prompting, I set the model at the cyber threat intelligence analysis. So what happened here? I want the model to produce me 3 parts of the threat summary report. The first is executive summary. And the second part is the detailed threat assessment. And the last part is that the vulnerability report with JSON format. So with this JSON format, that you can fit into other consuming system like SIEM or threat intelligence platform or EDR, XDR, or whatever you want to do with this data, or you can just copy and share with the other stakeholder as well. So the reason I show here that I set the verbal but is true. So that means I want you to see that the whole talking about reasoning of an AI agent. So in reality, that maybe that we set verbals is false, equal false to produce just the final report. So because that is the reason that you see that it's a bunch of data produced here. And to check that if we have the final report or not, and you can see here that the talk. So that means that the LLM, the AI agent, it keep reasoning about how they can treat them and how they can get the threat summary report. This is like the looping. It still keep observation and talk observation until the chain is finished. So it seems the chain is finished right now. And voila, this is the final report you have. So this is as you will see that it show you the 3 part, the executive summary, like you already have in through the reasoning process, and the detailed threat assessment, and absolutely the report, the threat summary report in the JSON format, so that we can reuse. And this have, you can see here that I can try to produce that. If you want to, can get some CVE here or CWE ID here, and the risk score and risk justification and some explanation and a recommendation. All right. Now that you see the potentials of this approach, right? I want to be a little bit transparent about the hurdles. So as you saw the demo, that the system is very powerful, but there's still challenges. The first challenge that the LLM sometimes provide inconsistent output. For example, if I rerun the demo again, the threat summary report I may have a little bit slightly little bit different. Maybe that some threat may be down from risk of down from high to medium, some risk is upgrade from medium to high, and some thread disappear or some thread appear. So that means that they still have some limited about the LLM model. So that is the reason that we come to the second one, the hallucinations. Sometimes that I check the report, and sometimes that the model generate some very plausible information there, but incorrect information. So that's the reason that we need to do some more like verification, validation after the step that we need to ensure that report is accuracy. And finally, when we there's still something that we need to consider about the ethical. When we do OSINT gathering from the internet, sometimes we gather that with the BAI, with the human people information there. And so then when we treat them in the LLM model, that we need to treat with the compliance, and also that we avoid to misuse those BAI data. So filter improvement. Basically, that the model produce a quite good for about quality for the report. But if you have the skill that you have can do the fine-tuning the model for better output. So for example, that if you have the threat intelligence data, or if you have the SIM data or other data, you can try to train the model, and that can produce a better report and also avoid hallucinations. And the second technology that you can use RAG or retrieval augmented generations. So that means that you can reduce, improve accuracy, and also reduce the hallucination as well. And further development that we can develop the domain-specific LLM model for cybersecurity or threat intel. And the last but not least, that you can see the AGI, the Agentic AI concept right now. So what you see here, what you see in the proposed architecture is just a simple and single workflow, and the AI agent there is just a basic agent. It's a stateless agent. It doesn't have a capability to do memory, to do communication further with other agents. So with the agentic AI concept, like you see here, you may have heard about MCP or A2A. You can increase the capability and increase the intelligence of the AI agent. And to wrap up, so I want to leave this with the final talk. What you can see that the two sides of a coin. So what you can see, just see that we have the OSINT combined with the generative AI. So it can be leveraged by either two sides. For the red team, it's a passive recognition. For the blue team, it's attack surface management. So the tool itself is neutral, and its impact depends on how you use it. Thank you, everyone, and for your time and attention tonight. I hope this presentation gave you a new perspective on how to leverage AI for attack surface management, or how to leverage generative AI for the cybersecurity. And I'm happy to take any question that you may have. Thank you.